Today we will review for the Unit 5 test. Alex Ovechkin of the Washington Capitals was one of the best players in the NHL during the 2009-2010 season. In fact, he finished second among all players in points with 109. Did he have a greater ability to score at home than he did on the road? So number 1 says briefly compare the distributions. So our shape, they're both skewed right. Our outliers. Home has 2 possible outliers. For center, home has a higher median. Remember, we use that because they're skewed. And home also has a larger spread. So number 2 says state the hypotheses. So our HO, Ovechkin had the same ability to score points at home and on the road. Our HA is Ovechkin had a greater ability to score points at home than on the road. Because the distributions are skewed, the difference in medians will be used as the test statistic. Calculate the value of the test statistic and describe how to simulate the distribution. So our test statistic would be our median for home, which is 2, minus our median for away, which is 1. So it gives us a test statistic of 1. We would take 72 note cards and write the points scored on them. Shuffle. And randomly assign $37 to home, and $35 to road. Calculate the median of each pile. Subtract home minus road. Plot it on a dot plot and repeat many times. Here are the results of 1,000 simulations as described above. Describe what information is provided by the histogram. So it shows the possible differences in medians, home minus road, that could occur by random chance, assuming Ovechkin had the same ability to score points at home and on the road. Estimate and interpret the p-value from the histogram. So, our value was 1. So if you go to 1, that's 400. So it's 400 out of 1,000, which is 0.4 or 40%. So assuming Ovechkin had the same ability to score points at home and on the road, we would expect to see a difference home minus road of 1 or more 40% of the time by random chance. Based on your p-value, make a conclusion. So our p-value is 40%. So we failed to reject HO. We do not have convincing evidence. That Ovechkin had a greater ability to score points at home than on the road. If we made an error, what type of error did we make? So this would be type 2. We said that Ovechkin had the same ability to score points. At home and on the road. But in reality, it was greater at home. Do noisy crowds in the Metrodome help the Minnesota Vikings play better defense? Here are the points allowed at home and on the road for the 2008 Vikings. Briefly compare these distributions. So if I draw over top of my graphs, I can see home is roughly symmetric. And road is skewed right. Road has an outlier. The median is higher for road. And the spread, which in this case is IQR, is higher for road. Prove mathematically that 48 is an outlier. So your median for road is 21.5. Your IQR is 13.5. So I would say 21.5 plus 1.5 times 13.5. And that gives me 41.75. 41.75 is less than 48, so 48 is an outlier. State the hypotheses we are interested in testing. So our HO would be the Vikings have the same ability to play defense at home and on the road. Our HA would be the Vikings have a greater ability to play defense at home than on the road. Calculate the median for each team, then calculate the difference in medians for our test statistic. So our median for home is 18.5. Our median for road is 21.5, which gives us a difference of -3. Remember, we want them to score less at home than on the road, which would show they have a better defense at home. So describe how to simulate the data. So I have 16 data points, so I would take 16 note cards. And write the points scored on them. Shuffle and randomly assign eight to home and 8 to road. Calculate the median for each pile. Subtract home minus road. Plot on a dot plot and repeat many times. A simulation was conducted that the Vikings have the same ability to play defense at home and on the road. In each of the 25 trials, the differences in medians was calculated and recorded on the dot plot. So for our p-value, we're going to go from -3 to the left. So our p-value is 10 out of 25. Remember always to look at the number of trials, which is 0.4 or 40%. Make an appropriate conclusion. So we failed to reject HO. We do not have convincing evidence. That the Vikings have a greater ability to play defense at home than on the road. A tennis player looking for an edge suspects that using warmer tennis balls will allow her to serve faster. Is this true? So what are the explanatory and response variables? So our explanatory variable is the temperature of the tennis ball. And the response is the speed of the serve. State the hypotheses we are interested in testing. So our HO is the player has the same ability to serve with warm and cold tennis balls. And our HA would be the player has a greater ability to serve with warm tennis balls than cold. How might randomization be incorporated? So we would randomize the order of the tennis balls so it would be like warm and cold. In order to minimize the effect of any other variables. What variables are important to control? So this would be like the type of tennis ball, the direction, the weather, the court, and you could come up with many other things to control. Will the player be blind? No, because she will have to touch the balls to serve them. Why might the tennis player want to compare medians rather than means? That would be if she suspects that her data is skewed. Suppose that the difference in medians was statistically significant. Can the player conclude that the temperature of the ball is a cause for a better performance in serves? In this case, we can say yes, because everything else is controlled.